Now, the vapor is now in dry saturated state condition at the beginning of the compression. At the beginning of compression, estimates the theoretical efficiency of the performance itself, which means it is telling that at the beginning of the compression, or the stage number 1, is vapor is in dry saturated condition, which means it is on the dry saturated line itself. Estimate the theoretical, our problem is to estimate, first of all, the theoretical efficiency of performance, theoretical CO2, and if the actual performance, coefficient of performance is 65% or 0.65 of theoretical value, then calculate the net cooling produced per hour itself. Refrigerant flow is also given 5 kg per minute itself. Hopeless. Just 1 second. The vapor is in dry saturated condition. Yes. What is the properties are given? Pressure is given. At the lower pressure is 9 bar, and saturation temperature, higher pressure is 9 bar, and saturated temperature at the temperature is given as 36 degrees centigrade, and that is the lower pressure is given as -7 bar, where the saturation is given as saturation temperature is given as -7 degrees centigrade. What is the percent? Now, what is given? It is what is shown in the figure. One is TS diagram here, and one is pH diagram here. Now, in the condition that is given is like this: the stage number 1, or the compression, begins at the stage number 1 itself. Is started from the dry saturated line here. So the point 1 comes the dry saturated vapor line of our refrigerant itself. So point number 1 is here, and point number 1 is here for pH as well as TS diagram here. As it is compressed from dry saturated line, we can simply think that it is after the end of the compression, it is in the superheated position area, because it cannot go as it is doing isentropically, as there is no entropy changes takes place from 1 to 2. So it's at the end of compression, it will reach to the superheated region at point 2. So the maximum temperature, what is the superheated temperature, that is T2, is not given, which is supposed to calculate it as per our requirement. And the maximum operating temperature and pressure is given as 9 bar and 36 degrees centigrade. 36 degrees centigrade here we are converting with 273, so 309 degree Kelvin itself. So 309 degree Kelvin is given as the high temperature in Kelvin scale, and 266 degree Kelvin is given as T1, or which is equal to T4. T1 is equal to T4, 266 degree Kelvin itself, and high temperature T2 is given as T2 dash temperature at the outlet at the dry saturated line, and T3 temperature at the outlet of the compressor and on the condenser itself. Now, actual coefficient performance is equal to given as 0.65 COP. So first we have to calculate what is the theoretical CP of the system. In order to calculate that, we have to find what is the enthalpy at 1, at 2, at 3, and at 4. Enthalpy, and what is given as enthalpy, the enthalpy in the liquid and vapor stage, and entropy of the vapor at saturated vapor. These are the given parameters which are given. So from here we can see HF3 is the HF3, which means here, or as well as here. The enthalpy at the point 3 on the wet saturated line is given here and which is operating at high temperature, along the high temperature line, the high temperature area itself. So 0.3 is equal to you have to choose from high pressure and high temperature line, and that as it is liquid entropy, it is given as 70.55 kilojoule per kg, like here. So H3 as well as H4, as H3 expansion process 3 to 4 is isentropic. So there is no heat, is not isentropic, I'm sorry, is under constant pressure. Here we are saying that there is no enthalpy loss. Enthalpy is reduced from 3 to 4, and it is in vertical line. So that is HF3 is equal to H4 itself. That is equal to 70.55 kilojoule. And HF1, the enthalpy of the fluid, represented at 0.1, which is given as HF4, which is somewhere here. This is the point of restriction here when which is given as 29. This is 29.62 itself. Just one thing, let me go through. Paper is part theoretical consideration. The isotropic, there is no undercooling in the condenser itself. Well, vapor is rise saturated before estimate at ठीक है. Okay, HF3 is the H4, which is given, and HF1, which is the fluid enthalpy at the point 1, which is the point of intersection of this line here, and which is supposed to be equal to HF1 is equal to HF4. So both these are on the same line from here and here. Point 1 is and point 4 is on the same temperature line, the lower temperature line. So HF1 will be here, and HF4 will be here. But H4, it is not H4 itself. So HF1, the fluid at the point 1 itself is given as